We're asked here to indicate the region that has all of these constraints, so that satisfies all of these constraints. And the first I want to direct us to are this one and this one. And that's because this says x is positive or 0 and y is positive or 0, which means the axes we choose won't look like that, they'll look like that. So that's why I want to establish what my x's and y minimum values are, so I know that these will be greater than 0 and I can pick the right axes. And here we go. Now don't forget, we do need to label them always, so we're going to label our y and our x. The next thing we need to do is we need to put all our lines in. So I've got 3x plus 8y and 24 and 3x plus 2y and 12. So what I'll do is I'll put these into the calculator and I'll see how they look. So here I am in my graphing mode, and let's get ready to put the equations in. The problem we have though is that the graphing mode wants us to give the equations in y equals mx plus c, which means we need to go over to the main mode and enter these in y equals mx plus c form. So remember, 3x plus 8y, I'm just going to do is greater than or equal to 24. So keyboard, maths 3, greater than or equal to 24, and I'll solve that. For y, remember always solve for y, then you get the y equals, and we get this. And my other one will be 3x plus 2y is greater than or equal to 12, and I'll do that as well. And you can see now, here we have both of our equations that I've written down from the calculator. So the first one looks like this, and the second one looks like this, and I've gone in blue and orange. Now what I need to do is I need to transfer these equations across to my graphing section. So I'll go menu, graph and table, and the first one I'll put that in. The second one I'll write by hand, negative 0.5 outside of 3x minus 12. Now what I need to do is I need to make sure I get the signs right. So it's y greater than or equals to, so I'll hit the equals and I'll hit the greater than or equals to. And then for the second one, I'll do the same thing, hit the equals, pick the right y and do an OK. Now the next thing I want to do is say I need both of them to be graphed, so I tick and I sketch. And what we see is that everything's concentrated way down in the bottom corner. And that's because my numbers for the graph, or my window for the graph, is too big. So I'm going to start using these numbers, 24 and 12, and start setting my window. So what I'll do is I'll say in my window here, my maximum is 110. Well, let's make my maximum 24 for x, and my y maximum is also 110. Let's make that 24. And the minimum values, well, we know nothing goes below 0. So let's make it negative 2 for each of them, which means we'll still see the axes at 0. And I'll say OK. And even now things are pretty small, but at least we have an idea what we're looking for. So you can see I have the red line and the blue line. This is my blue line here, blue, blue, and the second one, 3x plus 2y, that's my red line. And I can see that my region is the shaded region here, the one I'm looking for. So now that I've sketched these, the first thing I'm going to do is go to Analysis and G-Solve and Intersection, and I'm going to find where they intersect, which is the point here. Now everything's still pretty small. Let's see if we can zoom in maybe. And that doesn't help us at all, unless we move our graph across. Let's see, that's better. So now I'm going to go Analysis, G-Solve, and Intersection. And it tells me the intersection is where x is 2.666667 and y is 2. So I know that, and I'll make note of that in my notes. So the intersection is at 2.67 and 2. I also need to find out my y-intercept here and my x-intercept here, because it says I need to show all of the corner points of this region. So I need to find my y-intercept of the of the red line and my x-intercept of the blue line. And I can do that by just clicking one or the other, replacing this back with an equals, and saying, okay, for my blue line, let's sketch that. What is my analysis G-solve maximum? Sorry, analysis G-solve root. That gives me my x value. X is 8 and y is 0. So for my blue line, my x-intercept is 8. And if I go G-solve again to my y-intercept here is 3. It's got 0, 3 there. So I can write y-intercept equals 3. For my orange line, I can do the same thing. So I'll unclick this and click this, and I'll change my sign to an equals sign. I'll sketch it, and I'll find out that my y-intercept is 6. And my x-intercept root is 4. So now I have both lines, and I can put them in here, and I can say, okay, for this one, a y-intercept of 3 and an x-intercept of 8. And then I can sketch my line. So I'll get out my pen or my ruler, and I'll make sure I pass through both of those points. Oops. There we go. And the next thing I'm going to do is get my other line, and I'm going to go through 6 and 4. So I'll get out my orange pen, I'll get out my ruler, and I'll go a y-intercept of 6 and an x-intercept of 4. And there's that one. So I'll mark my points here. It's always nice actually to write coordinates. So that's at 0, 6. This is at 4 and 0. This one in blue here should be at 8 and 0 and 0 and 3. So there are my two lines. And now remember, my shaded region is this region here. So I'll colour that in. Look at my beautiful colouring. I could be an artist here, couldn't I really? And my point of intersection is at 2.67 and 2. And now what I've done is I've shaded the region in yellow. I have marked the coordinates of all the corner points here, here, and here. So these are my important corner points. And I've shown the feasible region, which I'm still colouring in because I'm just so good at it.